Hey class, this is Gigi going over practice with infinite limit. Question number 7. For us to determine the limit of x approaches 0 of x to the 4th power minus 5x to the 3rd over x to the 3rd. And the instructions said to use infinity, negative infinity when appropriate, or say that it doesn't exist. Okay, so when I'm reading this problem, I can see that there is a common factor of x to the 3rd. So what I can do is I can go ahead and factor the numerator out right here, x minus 5 over x to the 3rd, and then I can say, hey, I can go ahead and divide out x to the 3rd. X to the 3rd divided by x to the 3rd is 1. And I think that's important that we think about that as division, because when we reduce, we say that, hey, our function is going to behave like x minus 5 everywhere except for when x is 0. Because when we divide right here, we can say x cannot be 0. Otherwise, we are dividing by 0, and that's illegal, right? So now we can just say that that limit, substituting 0 in for x, we will have negative 5. Now, what we are saying is the function, in this case, the function f of x equals x to the 4th power minus 5x to the 3rd, all divided by x, is the same as the line y equals x minus 5 everywhere except for at x equal to 0. So when we're looking at the graph of this function, we are saying here, what happened when we reduce is that big function, right? That big function is exactly the same as the reduced counterpart, except for when the factor that you are dividing is equal to 0. So except for that, right? So how does this graph of f of x look like? The graph of f of x look like the line y equals x minus 5, which has a y-intercept at negative 5. 1, 2, 3, 4, 5. And the slope is 1, so it will be like this. And like that. And you have a hole at 0, negative 5. Okay, so this right here is the graph of the function f of x, looking exactly like the line y equals x minus 5, except for there is a hole at x equal to 0. And that's what the limit as x equal to 0 of that function equal to negative 5 visually mean here.